So once again, this is the Promoting Public Health with GIS panel. It is one of the last panels of the day. And we have two speakers that will be followed up by a Q&A session. Be sure to join the Slack space as well as use the join the room hashtag 2020 public health. And these are just some instructions to make sure that you make the most of your settings. And okay. So we have about 20 participants. I think we're ready to get started. Okay, so once again, welcome to the Promoting Public Health with GIS panel. This is the last panel of the day. And I am joined here by two panelists. The first person who will be presenting is Dr. Pushkar Imandar, and he is a data scientist in the Department of Epidemiology and Biostatistics at the University of California, San Francisco. And he is applying concepts like deep learning to perform remote sensing data analysis for neighborhood characterization and other geospatial data sets to identify health risk patterns and outcomes. So thank you very much, Pushkar, for joining us, and feel free to take it away.
Sure. Thanks, Albert, for the introduction, and let me share my slides. Okay, can you see my slides?
Yes.
Okay. So I'm going to talk about how we, Dream Lab at University of California, San Francisco, creating green space and blue space measures as a part of neighborhood environment to promote public health. So focus of this presentation is going to be about remote sensing data sets and application of GIS. At the end of this presentation, I have also included preliminary results of green space and blue space for California Bay region. So here is some background. So public health promotes and protects the health of people and the communities where they live and learn, work, play. So the neighborhood plays an important role where individuals live makes a difference to their life, health. So many green and blue space provides recreational areas for residents and helps to enhance the environmental quality of neighborhoods. So by definition, green space is a land that is partly or completely covered with grass, trees, shrubs, or other vegetation. So this includes parks and community gardens as well. Whereas blue space essentially includes visible outdoor surface waters, such as lakes, ponds, rivers, harbors. There are emerging literatures on natural environments that indicate these factors are likely to mitigate stress and promote health. There are also literatures suggesting green and blue space have beneficial health effect. Public health is growing field that is turning to GIS and remote sensing for research applications. So GIS helps in answering questions like where people are living, where are diseases starting, where are sources of pollution, etc. Also, incidence and prevalence are important fundamentals for using GIS in public health applications. So we at UCSF Dreamlabs team, we are using publicly available remote sensing images and applying machine learning and computer vision models to extract green and blue space layers. So there are two different approaches which are commonly used to study green space and blue space layers. So first one is proportion measure, where a percentage of green space and blue space is calculated, maybe using buffer area or other census level geographical units, such as census tracts or block groups, etc. And second approach is using proximity measure, uh, where distances are calculated um, from these green spaces uh, to the participants' locations or patient location. So for those of you who are new to remote sensing, here is just brief introduction. So what is remote sensing? Remote sensing is gathering of information through a sensor that is not in contact with what is being studied. So it's a collection of images or other data sets through an energy sensing device. So these sensors are mounted on different platforms. So those platforms include aerial platforms such as aircraft, satellites, and also air balloons sometimes. So these sensors detect patterns of reflected and radiated electromagnetic energy. Then we can use different computer vision models, such as machine learning, deep learnings, or traditional models to identify different patterns and features, and then we can separate those features. Some examples of remote sensing data sets include radar data, aerial photographs, satellite images, also LiDAR data set. Here are some characteristics of remote sensing. Uh, so first one is spatial resolution. So this resolution of an image refers to potential detail provided by the imagery. So in remote sensing, we refer to four types of resolution. So first one is this spatial resolution, which refers to the size of the smallest feature that can be detected by satellite sensor or displayed in a satellite image. Second one is spectral resolution. It refers to the ability of satellite sensors to measure specific wavelength of electromagnetic spectrum. Third one is temporal resolution, which helps in answering questions like how often is data collected. It refers to the time between the images, the capability for satellites to provide images of the same geographical area for different time periods. And last one is radiometric resolution. So this relates to sensitivity to the magnitude of the electromagnetic energy. So if data is collected for 8 bits or more than that. So this is the basic of special and different kinds of resolutions, which is helpful in deciding what images to use for uh, what kind of analysis. We at Dreamlab, we use combinations of approaches like remote sensing indices, segmentation, classification, to extract green and blue space from satellite images. So indices and band ratios refer to using combinations of electromagnetic wavelengths or bands, and using these combinations, we can then extract features from raster data set. So some commonly used indices are EVI, uh, uh, that is enhanced vegetation indices, NDVI, normalized difference vegetation indices, NDWI, this is the water index, and so on. So there are many indices. So where we use combinations of bands and then separate different layers. Uh, Other one is segmentation. So where we can partition different features from raster satellite images and then convert them into objects, so that we can actually quantify those different features at different geographical levels. And last one is image classification. It refers to the task of extracting information um, using different supervised, unsupervised classification algorithms, which includes maximum likelihood techniques, support vector machines, random trees, cluster algorithms, and also CNN and neural network models. So this is an example. These are preliminary results which we obtained. So first image is satellite image where you see different colors because it's a multispectral satellite image. And second is extracted layer. So if you see, only green layer is extracted from the satellite image using combination of different vegetation indices wavelengths like near infrared and visible band. So here each pixel it represents percentage greenness covered for that area. So here each pixel is 10 by 10 meter resolution because so original image is sentinel image. So special resolution here is 10 meter by 10 meter. So once we extract this using combination of segmentation and indices, then we can convert this raster layer to GIS layer, and this is assigned to different census tract. So here you can see percentages like 0 to 16, which refers to percentage of green cover inside that geographical level. So this is just one application where we extracted greenness using combination of different methods. Next one is, so this one is high resolution, 1 meter by 1 meter. You can actually see and distinguish different objects here. You can see individual trees, also different buildings. You can separate different features here because this is a high resolution image. In subset, you can see one street segment, and actually you can identify individual trees over there. So this is the result after using segmentation. Here we can actually count number of trees in a GIS layer. So once objects are created, we can see uh, different canopy covers as a polygon, and then it allows us to calculate number of trees for particular tree segment. And this is for that entire area in Oakland, California. So where we can actually see number of trees where they are located, and also some grass cover, and it allows us to calculate um, um, this count for number of trees for that particular segment, as also for uh, inside block group. Now, third application is we can also identify park spaces, which comes under green space. Uh, Here I have marked uh, some parks from San Francisco downtown. Like you can see here on the left side is extracted layer, like Oracle Park, and on the right top, as you can see on Google Map, how it looks. So it helps us also separating these different layers from green space. And then later we can use proximity measure and identify distance between parks and patients, uh, which can be used to study different public health uh, aspects. This one, this is the last result slide where we can see blue space is extracted in similar way as green space was, but this one is using different indices which are specific to water feature. And then on the right side, you can see this percentage water area is assigned to census tract level, block group level, and we can see a high percentage where there is lake. So in summary, we can use remote sensing and GIS to promote public health. We at Dream Labs, we are using green space and blue space measure to look at associations with health among Kaiser pathway cohort of breast cancer survivors. Remote sensing enables us to identify different modifiable environmental risk factors. We can study vegetation as well as also different blue spaces using remote sensing, and its repetitive coverage of very large area enables us to cover different themes. We can also study air pollution, which is like dynamically changing a measure. And single image captured through remote sensing can be used to analyze different measures. So just one image does not provide just one measure. So we can use this for multiple measures. And most of these remote sensing data sets are freely available. So it saves a lot of money. Here are references which I have used, and this project is supported by Pathways, a prospective study breast cancer survivorship from Kaiser, whose PI is Larry Cushy. Here are some resources, DreamLab and Geospatial at UCSF, where you will find some geospatial related resources and also similar projects. Thank you. If you have any questions, please ask.
All right. Thank you so much, Pushkar. That was a great use of remote sensing and public health. So yes, as you mentioned, if you have any questions, please feel free to drop it in the Q&A, and we'll have time to answer it after our next panelist. So now we are joined by Heather Chow. She is going to be presenting on GIS and public health, undergraduate insights. And so Heather is a undergraduate second year at UCLA, and her major is geographic information systems and technology, as well as a potential minor in public health. And with that, I will turn it to Heather. Thank you for joining us.
Hi guys. Okay. Hello everyone. My name is Heather Chow, and thank you, Albert, for the introduction. I am a second-year undergraduate student at UCLA. I am a geography major and GIS minor with a prospective minor in public health. Today, I will be diving deeper into GIS and public health from the perspective of an excited undergraduate student getting started in this field. So I'd like to start off with this question that every college student probably dreads being asked at the Thanksgiving dinner table. What are you going to do with that? Where the word "that" refers to geography and GIS. Quickly followed up by, is that geology? Do you just literally make maps? When you first began your journey in geography and GIS, I am sure many of you might have been repeatedly asked a similar question to this one by your non-geography peers, friends, family members, and even strangers with whom you might have introduced yourself to. Initially, people's ignorance really made me doubt my future plans with geography and GIS, and for a long time, I have always had an affinity for healthcare and the biological sciences. Being inspired by scientific innovations and my parents' work in the healthcare field, as well as being an avid long-distance endurance runner who is a strong advocate for healthy lifestyles and the outdoors. And so far, to my current knowledge, I have not encountered or knew of any other geography major and GIS minor in the chemistry and life science classes that I have taken so far. Generally speaking, as the outlier among my pre-health peers, I felt very intimidated and lost during my first year as an undergraduate at UCLA. But today, I hope to share how GIS is an effective tool in channeling your passion into whatever suits your calling, just like what I plan to do with public health. To respond to that overhanging question of what are you going to do with geography and GIS, I wanted to identify the root of that question. And doing this required a deeper reflection into my interests, asking questions such as, who do you want to help and serve, and why? What is driving you to dedicate your energy and enthusiasm and care towards the people who you want to help? And how do you want to make yourself a useful asset for the greater good of the community? Despite being the outlier among my pre-health peers, as previously mentioned, asking these types of questions really helped to spark a certain excitement about being different from the rest. And in fact, being the outlier made me even more excited to explore about the world of GIS. The more I learned about public health, the more I realized how much I loved the GIS work I was doing and how useful it is. The simple joys of the task and finding different ways towards a solution fed into my enthusiasm and curiosity for GIS, and public health was something that truly spoke to me loud and clear, motivating me to incorporate a GIS experience into practically everything I do. For example, as the GIS representative for UCLA's Geography Association, I plan to not only create my own outlet for GIS uses in public health, but to also encourage others in the association to do the same in their own field of interest. And most importantly, to all learn from each other. And another example of how I plan to expand my excitement for GIS and public health is through my involvement in a pre-health professional student organization known as Asian Pacific American Healthcare at UCLA. I am part of a mental health project where my research team and I plan to use maps to understand the relative geographic distribution of different types of mental health or psychiatric services around Los Angeles County, especially in areas with higher concentrations of underserved Asian and Pacific Islanders. So rather than being like the oddball in my academic and student involvement, I decided to challenge myself and show how I could actually combine both of these passions, which is something beyond traditional undergraduate paths that GIS has enabled me to do. And as you can see, whereas I had been caught in this in between with a black and white image of healthcare and geography, I decided to channel my excitement for these two interests into public health, which I see as that gray area in the middle or a combination of the best of both worlds. So this slide shows an example of the type of data collected by the mental health project team about the different types of mental health services in Los Angeles County, as well as the languages they offered and insurance types accepted, especially during this COVID-19 pandemic. Such information is critical for my team and I in preparing our data for a map rather than a spreadsheet to ultimately inform the public and provide better analysis on this public health issue. And so now is the perfect time to ask this question. Why do GIS and public health fit together? As many of you may or may not know, the capabilities of GIS are enormous in so many disciplines, and especially in public health. And broadly speaking, maps are providing meaning to our solutions, and they help raise awareness on issues that would be better understood with a visual component. So, I'd like to look at how public health isn't just a one and done thing. Rather, public health is more of a cyclic process and not a checklist. If we look more closely at what is called the public health approach from the eyes of a geographer, believe it or not, GIS plays an active and pertinent role in all four of these steps. GIS provides public health officials and researchers with the proper tools to carry out each step in the process. When we are armed with the data and the promising solutions acquired from GIS, we can pass these on to decision makers who have the power to ultimately transform these solutions from a meaningful map on display to a reality as seen during the implementation phase. And cycling back to the first stage of problem surveillance, GIS forces us to evaluate the effectiveness of those implementation measures and see how we can better allocate tangible resources to vulnerable communities in an equal and equitable manner. And it really keeps me in awe that public health is the working force behind the maintenance of our society's order, safety, and health without us even realizing it in our daily lives. GIS has given us a clearer understanding of the true nature of public health issues. And by showing how data plays out spatially as if they were living things, GIS has given us a better sense of direction as to how we as community members and organizations, researchers, institutes of higher education, professionals, developers, workers, business owners, and decision makers can collaborate together to translate solutions from maps and data to the human being. And as an undergraduate, just beginning to get my feet wet in the world of GIS, and like everyone else, living in a time where public health is in the limelight because of the pandemic, I am fascinated by the people in this diverse field and the GIS tools they are using to amplify this and so many other public health issues to cover a larger scope through mapping and spatial analysis. Genuinely speaking, the excitement I have in seeing the growing recognition of GIS's importance in public health has shown no signs of stopping. And although COVID-19 slammed the world this year and has taken a huge toll on our society in so many ways, the pandemic has forced public health and other industries to rely on the promising potentials and capabilities of GIS. From maps of daily cases, vaccination distribution, and hospital systems to masks and stay-at-home policies, social disparities, and healthcare or technological accessibility, GIS is constantly in action, searching for better solutions and tackling the community issue at large that eventually trickles down to impacting the lives of individuals. And to put it simply, GIS tools give public health issues meaning, and we need public health concerns to give GIS a purpose. So in the future, I hope we can see GIS continue to grow and evolve in public health. And I hope that we can witness how GIS and geography can give public health issues a voice. I also hope that as an undergraduate student, I can open the minds of other students to realize that GIS is not just maps and public health is not just healthcare, and to help them recognize the prominence of GIS in their own lives. And as an outlier among my pre-health peers, I thank them for their doubts and their questions. I thank them for making me feel lost and doubtful because it drove me to search and dig deeper into GIS and not just discover its possibilities, but to act on it. So I'd like to close off with some final words. Whether you are just beginning your journey with GIS like me, or have been doing it for 20 plus years, not being afraid to step outside the box and feel different will not close, but open more doors of opportunity to you. And no matter what level or area of GIS you specialize in, your work will not go unnoticed and will continue to inspire people like me day by day, sparking ideas and helping us to find a direction and most importantly, getting us excited. And to anybody who is still in the process of self-discovery or learning about the vast capabilities of GIS across all industries and services, it is perfectly okay to feel lost, just like how I was. In fact, you'll probably discover more about yourself and your callings as you go. Thank you. And if you have any questions, I'll be open to answer them.
All right. Thank you very much, Heather, for the inspirational notions of how public health and just GIS at large is kind of speaks to all of us. So we actually do have a question from Jason. However, I do want to also invite Pushkar to come back into the chat because now I would like to open it up for a Q&A. So Pushkar, thank you for turning back on your video. So the first question is for Heather. Did you get interested in public health before COVID-19? What inspired you to get involved in public health?
Yeah, that's a great question. So I always felt that I had a particular calling for healthcare. And as I mentioned, being inspired by my parents and my hobbies, I've always really had an affinity for healthcare. But especially during quarantine and during the COVID-19 pandemic, this kind of issue in the world, in our society, has cemented my passion for pursuing public health. And it really showed me, it helped me discover more about myself during this time being at home. And although it's not ideal, I've learned so much about myself and so much more about what really calls to me. So yeah.
So I have another question. Jason, you already asked one, so I'll go after. From Sophia, Heather, where do you see yourself going in the public health field after you graduate? And what do you want to do specifically? I'm a biology graduate who's been aimless for a few years now and wants to get into public health / sustainable development and contemplating doing a continued education course in GIS now. So she's curious.
Yeah, well, I'm glad you're pursuing public health and looking into sustainable development, because that is an amazing field. But seeing myself in the public health field after I graduate, I do plan to pursue graduate school. And as of right now, I am taking a mixture of the pre-health classes that many pre-med students are taking, including all the biology kids and the chemistry and all that, in combination with geography and GIS classes. So I'm not too certain of a set direction of which graduate school yet. I'm only a second year and I'm still discovering and exploring. But as I go, I really do feel that I want to pursue a higher level education in graduate school, and maybe hopefully apply to maybe different social work academic aspects in other universities, whether it be UCLA or other universities as well that focus on public health, and how I can implement my GIS techniques and tools that I gained during my undergraduate years, and how I can apply those to my graduate school career. So.
Awesome. Well, thanks. Jason, I'll get to your question again, but let me ask a question to Pushkar from G. Allen. How much of your data relies on open source data, i.e. Google Earth versus LandView, SAT versus L3, or other commercial imagery resources?
So we at DreamLab UCSF, we use open source data sets only, which are like freely available. There are many high resolutions images available from NASA and also European Space Agency, so which are like freely available data sets. And for our application, they are sufficient. So we mostly rely on open source data.
Excellent. I have a follow-up personally. So I was going to ask both to Heather and Pushkar, because it seems like data is being used repeatedly to make informed decisions in public health, both with the satellite imagery that you just mentioned, Pushkar, and Heather with your spreadsheet with the APA Mental Health Project. So one question I have is, what issues are there in maintaining those data sets to keep them up to date and relevant? And how do you collaborate with those within your organizations to get that data? And Pushkar, obviously you're getting it from open source, so it's a little bit harder, but yeah, just throwing that out there for both.
go first.
So sorry, I missed your question actually. So what do you say?
My question
What
was
did
just
you...
how do you help to maintain those data sets, basically, or how do you, because like those decisions are being relied on, but like for the open source data, like do you contact these people, or are you just mainly just getting the latest data sets?
So I guess your question is about reliability of data. So there are different ways to assess accuracy of these data sets. So fortunately, we have ground truth data for like green space, which I presented. So generally, we do some statistical analysis to see and understand reliability of data. And if we can just, so we perform some tests, and based on that, we use the data. But most of the time, in case of remote sensing data set, they are reliable because we because it's a satellite image, we see what's there, and except errors like cloud cover and some other maybe forest fire, if you ignore those kind of errors, then I guess most of the data is reliable.
And for my data set, in regards to the mental health project that my pre-health organization is doing, actually, most of the data is collected by from my team and I. We would, look around for mental health clinics and services in throughout different service planning areas in Los Angeles County. Because Los Angeles County is broken up into what are called SPAs, which are service planning areas. And we would focus more on service planning areas that are highly concentrated with underserved populations of Asian and Pacific Islanders. And we mostly actually target population areas where our health organization, we would host health fairs across San Gabriel Valley, where we would drive up there, drive to different locations, and perform free health screenings for people of Asian or Pacific Island descent, and who are typically at a lower socioeconomic disadvantage. And so we usually we would try to focus our search for mental health services in areas where the clients that we serve, where they reside. So, and in maintaining the data, it's constantly being updated. And so far, we found like some areas that actually have much higher concentration of mental health services, whereas others are very lacking in them. And and with this COVID pandemic, we've been trying to keep our keep our clients updated with these kinds of information, and to make sure that they get the most accurate information possible. And we would also directly call the clinics for more information about what types of services they provide. Are they going virtual or in person? And what languages they provide, since language is actually a very big cultural barrier to a lot of these populations, and make them be at a disadvantage in receiving healthcare access.
Great, thank you. Going to Jason's question regarding GIS, are there any fields, and this might go for both Pushkar and Heather, are there any fields that you feel couple really well with public health, GIS, besides public health?
I would say data science. It covers like a broad area, which involves different kinds of spatial, also non-spatial data sets, and you can then use combination of these data sets, and it allows us to use machine learning and other advanced statistical modeling techniques, I guess, which goes very well with public data sets, because there is very large amount of data available. Um, and with data science, it allows us to combine all these different aspects, spatial as well as non-spatial. So I would say data science very goes well.
Yeah, and maybe just add on to that. There are just so many disciplines where you can actually apply GIS to that many people probably won't think about. And I know that there's a lot of, if you're interested in economics, there's a lot of, using GIS for business and finance and all the logistics behind it. So besides GIS and public health, which in public health, there's actually different sections of public health. So there's like epidemiology and biostatistics and community health and all that. So there's a lot of options using GIS.
Yeah, there's even a business analyst module for ArcGIS, which people use. So yeah, that's a good point. So Sophia asks to Heather, I think, any research area you'd particularly like to study? Pre-health classes were fun. I love anatomy. Best of luck. Happy face.
Well, thank you. Pre-health classes are very fun, very competitive, but research area I hope to study. I'm particularly interested in, I mean, they're all very interesting, but I really feel that epidemiology is one that really calls my name since it does combine a lot of my interests for the life sciences, but community health is also another big one on my radar because of, I'm just so passionate and, I just love motivating people to, be in good health, and to put it simply. And but of course, community health doesn't just is not just limited to healthcare. There's gun violence, domestic violence control, and all those kinds of things that people have a narrow mind about. So research area, I'm still keeping my mind open and my options open, but those are two really big areas for me.
Thank you. Yeah, it is. I mean, it's a lot of potential ways you can use GIS there. This is for me to both panelists. In your opinion, what level of technical expertise and knowledge to get started with GIS and public health do you think we need? And how do you suggest getting up to speed?
I guess you don't need that technical knowledge to start with GIS and I guess public health, just basic understanding of science and some logical understanding how things work. Because in I guess GIS, everything is based on Tobler's first law, which is like near closer thing are closely associated. So if you have this kind of basic understanding, I guess one can do good with this GIS and public health.
Yeah, that's a great point. And as just a very, very beginner of GIS, being introduced to even just the foundations and of GIS and trying to, running into obstacles and class projects and, labs and all that, it's they're all learning curves, and they all build up to, add on to your skill sets and the tools that are available to you. So, taking my very first GIS course in last summer, just finding that joy in the work and the obstacles and of course the final product, and finding how you can go back and improve upon it. So that will prepare you ultimately to in pursuing public health and GIS.
Thank you. So I guess Katara Lee is asking, what projects would you both like to work on next?
I'm open for any projects which involves spatial data sets, and I'm more interested in um, public health. Means if you have some data set which involves like some patient data set, just hypothetical example, and if aim of the project is finding what are the reasons of that particular disease, then I would love that. Then I can use all my expertise and knowledge, I guess, efficiently to answer those questions. So yeah, but I'm open for any projects with any special data set.
Yeah, that's pretty much the same for me as well. I guess in the upcoming future, um, I am also part of another APA Asian Pacific Islander project, and we look at a lot of physiological data gathered from our health fairs and health screenings of our clients that we serve. And so I hope to take their information, the data, and to map it out, and where these people with certain health conditions, where they reside, and you know analyze the things that are around in their community that might be influencing their health and their health outcomes. So, but for the future, just like Pushkar, I am very open to exploring new projects and seeing what we can do.
That's great. Yeah, it seems like there's a lot of, again, opportunities to do that and apply. And I guess kind of related to that is how's the reaction of GIS, bringing GIS into public health received by your peers or people you've worked with? So, I mean, this could be also related to the projects question, but just like, have they been thrilled to hear about maps, or, are they just like their mind glosses over when you talk about like remote sensing and machine learning with the open?
Um, GIS is not new for public health. So it all started with Snow's research about cholera outbreak and how they found out the source. So GIS is not new, but all these additional data sets like remote sensing and all these new techniques like convolutional neural networks with cloud computing, these are very exciting, and all these are open source data sets, and we can use all these neural network models and other machine learning models using Python and R. So it's very interesting because we can actually develop all these images cost free, and means all these measures plays very important role in any statistical models when we are trying to find any patterns and trying to find any association. So um, all these new techniques and all these data sets are, I guess, very helpful, and people who are in public health, they are very interested in this new technology.
Yeah, and I guess just people's reactions when I tell them about public health and GIS and all these things. Of course, they're kind of like, whoa, what can you do with that? And I think just people don't realize that GIS is literally the one it's the force that's, I guess, maintaining the structure of our society. And without GIS and planning and analysis and all these GIS techniques, we wouldn't have water, waterways and we wouldn't have, I guess, all these things that make up our society. Just the whole daily functioning of our society, it needed, GIS and planning. You need maps to, really plan out how our society will be run. And I think just people there's not enough, I guess, awareness and recognition of what GIS has actually been doing for our society. And so I think that people, I guess we need to, I guess, expose GIS a little more to people, and so to change their reaction.
James actually corrected me on that. I think Valentine Seaman's map of yellow fever was predating Snow's map of cholera. I accidentally said that it was probably the first GIS map. Sorry. I guess in the notion of Heather, when you mentioned the public health method, and I was just wondering, Pushkar, how do you see your remote sensing findings going beyond that first step, which is identifying the problem of problem surveillance, basically? So how do you move to the next level with trying to find solutions or recommending solutions? And
So question is about what we do next once we extract
Yes.
data from remote sensing data sets.
Yeah, your findings, what do you do after those findings?
Yeah, so it depends on questions. So what the hypothesis is and why we think that we are creating that measure. So I guess it depends on that. But once we extract features from remote sensing data sets, we try to first, as you ask, like how we validate. So first we validate, make sure that data is correct, and then we see if we can use that measure to predict something, or if we can use that that particular measure in model, statistical model, in understanding associations. For example, if people living in particular neighborhood, if they are getting affected because of some environmental factors, like suppose there is less green space, maybe that's why they have some mental issues or some psychological issues. So we can study all these things. So once we extract all these measures, we use it in different statistical model and try to see if they are contributing to understanding correlations and association between target variable and independent variable.
Well, another question for Pushkar, actually, coming from G1 Yao. Why breast cancer survivors in your research? Are breast cancer survivors recommended to go outside? Does green space have more effect on breast cancer survivors?
So yeah, so it's just one project I mentioned here, which is going to use this measure. So it's not just that one project, but there are other cancer related projects. So it depends on literature reviews and what other researchers found out. So there are some research in this area, in breast cancer area, which they found association of stress levels with this green space and blue space, and based on the effect of stress on those among breast cancer survivors. So because of that, we are using this particular measure for this study. But it's not like we are just going to use this measure to understand association between among the breast survivors, but also other cohorts from other cancers and other diseases.
Okay, we have a couple more minutes before we wrap up this panel. Any other questions from the audience? As you can tell, I'm probably ran out of questions, but I am more than happy to ask others. For example, I can see one question about, Pushkar, you use a lot of remote sensing data, which is heavily raster based, and Heather, your information is probably going to be more vector based in terms of points for hospitals and buffers around that. Do you see any potential crossover between the type of work that you're doing on either data sets? And I saw, yes, well, go ahead, Pushkar. Go
ahead. So even though it's a raster data set, we can convert it to vector data set, and also we can convert vector to raster data set, or we can use combination. So we can extract raster based on vector data set. So it actually depends on what we are trying to achieve. But definitely we can use both data sets to analyze. It completely depends on hypothesis and what questions we are trying to answer.
Yeah, I do agree with that. And, just, yeah, like you said, it depends on what we're trying to, focus on. And for example, when I'm focusing more on, using vector data to perform the analysis, it's very flexible where I can, incorporate raster data and see where these populations live in, and, analyze what's around there, whether it's environmental or whatever might be affecting their health outcomes that we are seeing in the data and health screening results that we gather.
Yeah, thank you. Yeah, I was just wondering if, like, yeah, because a lot of the data sets, yeah, do exist in different forms. So that's definitely a good point that they're interoperable and you can go from one to the other. Any other questions? I can keep coming up with these types of weird ones, but I do want to mention that before we go, if you have any last words you'd like to share with the audience, and any other ways to keep in contact, definitely join the Slack. Pushkar, go ahead, you're unmuted.
I would say keep mapping, keep doing spatial analysis, because this is really important, and I guess you should keep doing it and try to apply wherever you see possibility of application of all this GIS techniques.
Yeah, I think I just think that even during these times, of course, I know it's very challenging for everyone, but try to immerse yourself into this kind of, these kinds of the world of GIS, because this time is so precious where we can take advantage of this kind of technology, and I guess play around with it and explore more about it and see what you can actually discover. And people in all these different industries, find out more about what they do and what they use it for and for what purposes, and just keep asking yourself questions and to stay curious and excited.
Yep, very good points, both from Pushkar and Heather. Stay curious and excited and keep mapping. So definitely, yeah, I do want to thank you again, both Heather and Pushkar, for taking the time out.
Thank you.
Join us.
Thanks for asking wonderful questions.
Thank you. Yes, especially to the audience too. Thank you for asking questions and supporting. So again, Danielle, thank you for putting that in the chat, that we will be having a celebratory map up and debrief shortly after this in that Zoom link. And Danielle, thank you for helping to support. If anyone doesn't have any other questions, definitely feel free to drop by. It's more of a social and networking event. And so, yeah, I look forward to seeing everyone there, and thank you.
Thank you so much.
Yeah, thank you. Bye.
Bye, guys.